Okay, so here's some trig equations here. Just like solving anything else, you want to try to get your variable all by itself. Well, in this case, our variable is theta. Really, the easiest thing to do is just to get your this basic trig function all by itself, and then as long as you know your unit circle values, the problems aren't that bad. So we'd want to first get rid of the 1, then get rid of the negative, and then figure out on the interval from 0 to 2 pi, not including 2 pi, because 0 and 2 pi are the same angles. They're known as coterminal. So therefore, I'm just going to solve for cosine theta and then figure out whenever cosine is equal to the value that's given here. So just like solving any other linear equation, I subtract 1, even though this is not linear, it's trigonometric, but it still behaves like a linear. I get negative cosine theta equals negative 1/2. I divide both sides by negative 1. I don't know why I'm writing this out. I get the cosine of theta is equal to 1/2. Cosine of theta equals 1/2 when theta is pi over 3, and in the fourth quadrant that would be 5 pi over 3. Okay, so again I want to get sine theta all by itself, so I need to get rid of the 2 and the 4. So first thing I'm going to do is divide by 4. So I get the sine squared theta is equal to 1/4. I then take the square roots of both sides, so I get the sine of theta equals plus or minus the square root of 1/4 is 1/2. So it's really every time the sine is equal to 1/2 is all the pi 6 angles that go around the unit circle. That's 5 pi over 6, 7 pi over 6, 11 pi over 6. So try to get sine theta all by itself. So I subtract 1, so I get 2 sine theta is equal to negative 1 because I subtracted 1. Divide by 2. I get sine theta equals negative 1/2. So theta, sine is equal to 1/2 at pi over 6. But since it's negative, that's going to be the third and fourth quadrants. So that's going to be 7 pi over 6 and 11 pi over 6. This next one's straightforward. Get the cosine theta all by itself. Cosine theta equals negative 1. Theta equals pi. That's the only time. All done. Okay, so here I have cotan. First I got to get the 1 and then get rid of the radical 3 and then consider cotan. So I subtract 1 from both sides. I get radical 3 cotan of theta is equal to negative 1. I divide by radical 3. I get the cotan of theta is equal to negative 1 over radical 3. I'm not checked off on cotan. I'm much better at tangent. So tangent is equal to negative radical 2. Radical 3. These two statements are the same. Cosine equals radical 3 at pi over 3, but we want negative 1, so that's going to be in the second quadrant and the fourth quadrant. So pi over 3 angles would be 2 pi over 3 and 5 pi over 3. Here's another reciprocal function. This time it's cosecant. So that stop is kind of in the way there. So I add 3 to both sides. I get 5 cosecant theta equals 5. Dividing by 5. I get cosecant theta is equal to 1, which is the same when sine is equal to 1. I just tried to write the answer there. Sine theta equals 1 at pi over 2. That's the end of that.